try to take you through an example of a gas plant up in Norway. I guess everyone knows where Norway is, right? I hope. It's far up north. And it's a Shell-operated plant, and it's delivered with the ABB system called 800XA. It's an automation system, a distributed control system. And look at how we have applied remote, what I call remote integrated operations on that particular plant. So first, very quick presentation about ABB, then take you through what is the plant actually doing. Then look at the service concept. I think one of the really key elements in remote operation is how you apply a service concept to it, so you can draw on the expertise that you really need from the different vendors in the industry. Then take you through 3 examples really where we have applied remote facilities. We have remote condition monitoring, as we have heard about also a bit before here. And then we do also some actually online tuning of the process. And then we have something called the armor room, which is our way of having one room which is outside the plant, but when you enter into the room, you are actually part of the plant. So the integrity of the plant still lies at the site, but you can sit in another location and be a part of the live operation of the plant and the process. Then I'll show you a small film on how it actually works and where we apply the armor room so you can see how it works in real life. And then a quick summary. So first, very quickly about ABB, we are 120,000 employees now, so 170,000 is a little too small there. 32 billion in revenues, and what we do is mainly provide services and equipment to the power and utility sector, and also a lot of the industry sector like oil and gas, which is example here. The equipment we provide is particularly power equipment, some rotating equipment, and of course automation as well. It's even instrumentation. So it's a wide range of equipment that we provide within what we call the white disciplines, which is the EIT, electric instruments, controls, and telecoms. So Ormen Lange, that is, I should really have a map here, but it's really on the west coast of Norway. It's quite in a remote location, so if you go up there, you have to, from the nearest airport, you have at least an hour's of transport to get there. It will take you quite an hour's car ride and then a ferry across to the site. So there's not a lot of people there, there's not a lot of infrastructure there, so that's why we utilize a lot of remote operations on that particular plant. It is a gas plant, so it's a gas processing facility. It has some 25,000 IOs, so it's not really a huge plant in terms of oil and gas, but it's a fair amount of IO. Excuse me. And the plant itself is located onshore, but you have subsea tie-ins like wells coming from offshore from the sea, and they're tied into the onshore plant. Do you think it's possible to have some water? Great. The plant is providing gas to the UK population, so at its best, when it's running on high, it can provide 20% of the gas needs in the UK. And that, I mean, then you could see that, thank you. The plant itself will, if it stops, affect some at least 10 million people over in the UK. So that's quite a lot. So it has some it has some interest in running on full power. The production started in in 2007, so we had some operations over in the last 3 years. One of the really key elements here is the service concept, and that's the backbone of how they are operating the plant. One of Shell's objectives when they started this and designed the plant was really to keep the staffing at the site and also in the Shell operations team at a fairly, let's say, core level and as low level as possible. That means that they want to draw on the expertise that we have in the vendor community. And to do that, you really have to have a really secure and stable service system so that you know that you can rely on your partners and your vendors in this process. So if you look here, we have the basic service concept is really the service level agreement, where you have building blocks on top of it, and you can use how many of these building blocks as you like. But really, Shell takes the full concept and applies it as a whole. So a couple of examples here is where you have the armor room is here. And you also have the configuration database, which is really a database that tells you where all the equipment is installed and what is installed in what part of the plant. So if you have a failure, for example, on an I/O card or some piece of equipment, you would immediately be able to link that failure into the configuration database, and you would find out which revision number of the card and which batch of the production is the card. So you can replace it and make sure that the replacement is the exact same part as failed. So that's a very, very important part of the service level agreement. And then up here, you would also have a remote alarm management. So you would get the alarms from the field into the control room, and you can pass it on to the supplier and the service desk, which is this piece of the service level agreement. So this is really a backbone for their remote operation in Shell, and they see this as a very, very important piece of how they operate the plant. When I talk about remote integrated operation, this was really the basis and the outline that we said would be the targets for integrated operations when we designed it. And you see the saving numbers up here. So if you take the OPEX part, which is the middle piece here, that would be some 15 to 20% reduction in OPEX number. That was really the target from an operational point of view. And then we said that also the integrated operations would provide you with the possibility to get better well performance, and you would get better throughput and better reliability, and also HCC numbers would be affected. So the performance part of the target was really somewhere around 20%. So we would have 20% OPEX, 20% better performance on the plant and the process itself as a target. And I get to where Shell is at this point in time. And one of the really critical things that we said when we designed this was the technology is there. I mean, there's no worry about the technology. We all know that we have high bandwidths and we have really advanced application that we can apply on any plant, even an oil and gas plant, which is a very conservative type of industry. But the problem lies with the work processes. People have to change to kind of get used to that you actually manage a plant from outside sometimes, and you actually apply some remote type of facilities where you don't sit actually physically at the plant and do the work. You sit actually somewhere else. And that's a mental change, I would say, for most of the process operators in the industry today. So that's what they also said, Shell, that this is very, very difficult for us to change, so we have to really change the mentality of the people on the site. So this is a part of the really big challenge they have faced. But they have made it, and they're quite up to speed now with I would say, the work processes and facilitated the work processes for remote operations. And of course, for them, it's one of the big objectives was to enable people to take better decisions and do it faster. So you have the data points at your fingertips where you can actually make sure that your decision taking is correct and that you do it as fast as possible without going out going out and actually see the piece of equipment and see how it looks like before you take a decision on whether it's going to be replaced or repaired or whatever. Then